My name is Kyle Paz. I'm from Pitney Bowes. I'm going to be talking to you about how Pitney Bowes is transforming our business in the cloud. I came to Pitney Bowes about 2 years ago, and I work on our SaaS platform and API platform teams, supporting many BUs with horizontal efforts. And we're going to be talking today about who Pitney Bowes is and what we do to enable global e-commerce, why and how we moved some critical AWS, critical workloads, Windows-based workloads into AWS, and what things we're doing next to accelerate the development of and the quality and reliability of new e-commerce services. How many people here know who Pitney Bowes is? Like, just raise your hand. All right, so about 2/3 of the room. Pitney Bowes, we've been around for about 96 years, and our iconic product is the mail meter. So maybe you've maybe used our mail meters working in SMB type offices, maybe a law office or a boutique retailer. That's our most iconic product, but we actually have a very, very powerful global e-commerce business that spans various solution areas, customer information management, so ingesting data, doing data quality cleansing, enriching data. We have a very powerful and rich offering of location intelligence solutions, both from a very rich and powerful data sets that you can integrate into your enterprise. We also have customer engagement solutions to allow you to more deeply and more contextually interact with your clients, as well as shipping and mailing solutions to drive parcel handling and mailing efficiency with end-to-end innovation. So today we're going to be talking about our, mostly in our shipping and mailing space, some of the interesting innovations that we have going on there, and some of the transformation work that we've done to make that business more efficient. So we're going to be talking about our shipping business, and we actually have a transportation network that does outbound business from the US to 104 countries worldwide. That's actually probably a dated figure. I'm sure it's grown since I put the slide together. We also have an outbound business from the UK going outbound to 88 countries, and we've also more recently added Australia. So we have outbound parcel business from those locations out to international locations. And really, this is what we're doing. We integrate with marketplaces. So for example, with eBay, and an eBay seller can choose to onboard with us to allow them to sell their listings to international buyers. And if someone buys internationally, obviously there's some complexity when a parcel wants to go across an international border, right? There's duties and taxes. There's a lot of complexity that goes into figuring out what's going to cost to get that parcel across a boundary. So, at the front end of this, we have integrated into the order capture system a capability to do that landed cost calculation and provide a guaranteed rate to the buyer that they can pay one simple fee that will guarantee that when they buy the parcel, it's going to land on their doorstep, and they won't have a situation where the delivery person arrives and they get asked to pay some amount of cash to receive the delivery because you have to pay the duties or taxes or some other fees. So if you buy from let's say you're in Canada and you're on eBay and you're buying from a US seller, great, you win the bid or you do the buy it now, you close your transaction, then that's going to initiate the seller to ship that package to one of our hub locations. In the US, we actually have a hub location in the Omaha region. I'm not actually sure where it is in the UK, and we also have one in Australia. In the hub team receives that parcel and processes it. Then from there, they're going to ship that parcel to a domestic line haul vendor who's going to get that ready to be shipped internationally. Then it's going to go through customs, get transported to the airport, be loaded onto a plane, shipped internationally. It's going to land. It's going to pass seamlessly through customs because of all the great work that Pitney Bowes has done to assure that package will clear customs. Then it's going to go to a local delivery, and then on to the actual buyer. And they'll be celebrating because the package arrived and it's just what they've always wanted. So I'm going to be talking about our transportation hub software. This is the software that's used in those hub locations, and it supports all facets of this life cycle. So the hub, in that hub location, when the packages come in, the package is inspected, and we want to make sure that it's going to match what was actually ordered. We're going to check the parcel weight and dimensions. We're going to check to see if it's a restricted or dangerous good. And by the way, this is both done digitally as well as some great physical innovations as well. I think Pitney Bowes, we're all about merging the digital and physical experiences. In our hub locations, we actually have some really magical electrical mechanical equipment that helps us do this more efficiently, and it's tightly integrated with this hub processing software as well. We're going to put together all of the documentation, a shipping label, the commercial invoice, bill of landing, the manifest, anything that's required to successfully get that parcel delivered internationally. We'll produce all that documentation. We actually will do the parcel containerization, so we'll group the parcels according to where they're going, according to the type of item they are, to make it easier for the line haul vendor to ship it and get that transported internationally. And we'll also integrate the parcel in the shipping label into our carrier tracking system, so we can actually have package tracking throughout the end-to-end journey of that parcel as it goes through all those phases of the life cycle I showed here, and all the way out to the end buyer in the successful delivery. So in 2015, we found ourselves in a spot where we had some severely aging infrastructure. The infrastructure that we were running this on was located in our Omaha data center. The server and network infrastructure was all pretty much 3 to 6 years old. It was fully capitalized, which was great from a cost perspective. However, we definitely were seeing insufficient I/O performance, so the workloads were just not running very efficiently. And this is a volume-based business. We run a lot of parcels, especially at this time of year, so performance and I/O throughput is critical for us. Also, we had a spook factor. Whenever there were performance issues or any kind of an outage, and we would get our operations team and our developers working together to look at it, we just did not have that confident feeling in the underlying infrastructure to rule out spooky things that could be happening at the network or at the disk or at the server level. That was always just slowing us down as we were working through these things and trying to improve the performance or resolve an outage. So not a good situation from an infrastructure perspective. We also were in a situation where we had our application development team and our application operations team, and I actually have a couple members of that team here today with me, working together with a NetOps team. The NetOps team was actually located in that data center, and they did all the racking and stacking in the maintenance of that infrastructure. And these three teams collaborate closely on the deployments and the upkeep and the maintenance and the outage resolution activities for this application. But we got the word that the NetOps team was going to be pulled back from this operation, right? They were being squeezed for cost, and they were being reorganized, and they were being reallocated to different activities. So that was going to leave our application developers and our application operations team a bit in the lurch. We were going to lose our on-the-ground NetOps people that were overseeing this critical data center for us. So what were we going to do? Lastly, we had a DR site. Now, this is actually a picture of Omaha, if anyone's familiar with Omaha. This is actually Omaha. And we had our primary site and our DR site in the same metro area. So we had DR, which was great, but this really was a disaster waiting to happen. When there's a disaster, it can impact a whole metro area, obviously. And so we were just not in a great situation, so we need to probably better prepare ourselves for disasters in the future. So we had some decisions to make. So what did we want? We wanted a new solution that was going to get us into a OpEx versus a CapEx spending cycle. Obviously, we want a cost-effective infrastructure. Who doesn't want that? we were also looking for developer productivity. This is something that was really important to us. When we started looking at what were we going to do hosting partner-wise, it wasn't just driven by our hosting operations team. This was a joint effort between that hosting operations team and our development team. And actually, a member of my team here, Kevin Bodie's here today, who was a lead member of that team. And developer productivity was really important for us. That was a really key consideration for our decision. And also, we needed reliability. Pitney Bowes, we've been around for 96 years. We're a well-established brand. Our clients, both our SMB clients as well as our enterprise clients and partners, they have an expectation of our solutions that needs to be, our reliability needs to be commensurate with that 96-year legacy that we have. So we needed a reliable solution. So we started looking at a number of vendors. We looked at, obviously we're looking at AWS. We've also looked at a number of other public cloud vendors as well as some other colo solutions, and really looked across these areas to see how they scored. And really, in the end, what we found was that for OpEx versus CapEx, everyone's got that now. Everyone's got, even traditional colo vendors, they'll set you up with a pay-as-you-go situation. And for the most part, we found reliability to be pretty good across the board. With some exceptions. But when we looked at cost and developer productivity, AWS really hit the nail on the head for us. Just cost-wise, they were far and away the most efficient solution compared to what we were looking at. In developer productivity, we really saw all the investments they were making into the developer tools that you can use to more quickly get your applications out the door. Things like SNS and SQS, right? Those were some of the early developer productivity tools they built out. And this was even before they were building out really cool things like code deploy and code pipeline. So we saw where Amazon was going with that productivity story, and we really liked what we saw. So we elected to go with Amazon. So we're going to move the transportation hub to Amazon, and we started defining what our cloud adoption patterns were going to be within Amazon, or within Pitney Bowes, and we really identified 3 patterns. We had a lift and shift pattern, a cloud optimized pattern, and a cloud native pattern. The lift and shift, everyone's familiar with what that is. You take what you have in your physical data center and you leverage the cloud services to basically rebuild that. So for Amazon, you're going to be leveraging EC2, AMIs, VPCs to kind of define that network layer, elastic load balancers for load balancing, Route 53 for DNS. Actually, I see here in Cloud Optimized, I have elastic file storage. That probably should also be in lift and shift. So lift and shift, recreate your physical data center in the cloud. Cloud Optimized, this is really take your application, and development does some work to optimize that application, which might have been built in the days of the physical data center, but you start modifying that application to be more efficient and leverage some cloud services to improve your cost, improve your reliability, improve the quality of service. So this, really, you're looking at separating compute from storage. So you look at leveraging Amazon S3 for storage. RDS is a great way to improve your cost and efficiency. CloudFormation for monitor, or CloudFormation for deployment, and CloudWatch for monitoring. All great tools that we want to see employed at that cloud optimized pattern. And then cloud native, this is really where you are building an application ground up designed to leverage all the resources of the cloud. Elastic Beanstalk and auto scaling, very popular within PB. You can really get an app going and deployed quickly in Amazon with Elastic Beanstalk. And auto scaling, if you really are designing an application, separate your tiers, have each tier horizontally scalable, set up your auto scaling groups with the right policies to scale each horizontal tier independently, and you'll have a really cost-effective and high-performing application. And also Docker, we are our cloud-native applications. Many of them are packaging the application tier as Docker and deploying those Docker containers. Often through Elastic Beanstalk. And also, we're starting to get our feet wet with serverless architectures with AWS Lambda. So looking at the transportation hub, we quickly landed on we wanted to do lift and shift. Why? Speed was really important. We had to get this done fast. We were looking at getting this done, and we needed to be done before our holiday period freeze, which goes into effect at the end of October. So that's when we really start to expect our parcel activity to really start driving up as we head into November. We need to be completely frozen with this deployment heading into that time frame. We had to execute quickly and get it done. Also, development was consumed with delivering new feature content, and there just wasn't bandwidth there to look at taking on any optimizations to get to that, that cloud optimized pattern. They had to deliver feature content to meet the needs of the business to help grow revenue, so we couldn't disrupt them. And also there was an aspect of let's crawl before we walk. This is really one of our first ventures into Amazon, and we wanted to, lift and shift is great because it lets you get experience with operating a product in the cloud, but it also has a lot of constructs that your operations team will be very familiar with. So you're not looking at things like Beanstalk, which is a brand new concept if you've been running operations in a colo facility, but running servers, EC2 instances, great. A VPC network, that's a concept I'm very familiar with. So it was, let's get our feet wet, let's crawl before we walk, and as we get more mature, then maybe we can look at moving on to more advanced patterns. So it turns out that development had actually started this move first. And the reason for this was that around the same time this was happening with the production side, development was informed that the IT team, which at the time was managing the production environments, but also managing the lower development test environments, they were facing shrinking budgets and being squeezed for efficiencies. So they were going to no longer manage the development environment. So development had to figure out what they were going to do. And developers, they like self-service, they like speed, they don't like having to create tickets and waiting. So they quickly found Amazon and were able to build their lower dev and test environments there in a matter of days. And they started getting some experience with what it would be like to run the transportation hub in Amazon. And we work closely with our operations counterparts. They were pulling their ops team in, showing them what they're doing. And the ops team was starting to see that, yes, this looks like this is a potentially great solution for us for production. So development moved first for us, and they loved it. For the production migration, there was a set of key requirements that our operations team identified. One, it had to be a seamless migration from our colo data center to Amazon. There could be no impact to our clients or the customers of our clients. We need to get those parcels through and delivered to satisfy those end buyers. We absolutely could not jeopardize that at all. Also, we could not jeopardize the productivity of the development team. We wanted to do this without disrupting them, so that was really important to us. We wanted to improve the supportability of the system. As I said, we were kind of had that spook factor going. So we wanted to really make sure that going forward, once we complete this migration, it was going to be a much more supportable system, instrumented with much more rigorous monitoring tools, and able to give our operations team and development team the insights they need to successfully run this workload. We wanted to eliminate single points of failure. So in the colo deployment we didn't really have a great HA story in place. So that was important to us to look at what could we do to add high availability. We also wanted to enable seasonal bursting and scaling back down again. So we've scaled up now for our holiday period. Now that we're running higher volumes, post-holidays, we want to be able to scale back down again. And as I already mentioned, we wanted to complete that cutover prior to the holiday readiness period. So that was a critical requirement. So the first step in the migration was for our product services group, so our operations team. They built out what they call their production test environment. So here's a diagram of that environment. We actually set up four availability zones, and we also set up at the database tier. We're running MS SQL, so we configured MS SQL to be always on and be replicating across those two availability zones. This was completed, pretty easily. They got this built out in a matter of weeks. After they got it built out, they conducted load tests on that environment, and this is really where I think our operations team saw the power of the cloud is that they were able to tune the server configurations just over and over and over again until they got it just right, and didn't require purchasing of any new hardware. Right? I mean, a 6 to 8 week procurement cycle would have killed us if we had to get this done in the time frame that we're looking at. So just being able to tune your AMI configurations and spin up new instances and do another load test and then retune it again. For example, they discovered they need to increase the IOPS, and if we had actual physical hardware to do this with, that would have been all right. We need to order a new bigger disk or a new higher performing disk, and we would have been set back a number of weeks. In Amazon, it's just a simple config change. You can do it in a matter of seconds. It's tremendously awesome. Step 3, we cut AMIs from those tuned server configs and that we built out in that production test environment, and we used those configs to provision our production environment. So the same environment that we had finely tuned in our production test environment, we basically took that, built out our production environment from that, so we knew what we had in place exactly. And this, we learned something. So we learned that we didn't need 4 availability zones. We really only needed 2. But everything else was the same in terms of the deployment architecture. But now we had finely tuned server configs that was going to meet the needs of our peak workloads heading into the holiday period. So we were feeling really confident. Step 4, we replicated data from our Omaha data center to AWS. We configured AWS as the DR site for that Omaha data center, and then we failed over during one of our maintenance windows. And post failover, we were active in Amazon US East as our primary site, running production traffic. Then we configured a DR site. So we basically took our primary site, replicated it to US West, configured that as DR, took Omaha down, and now we're fully all in on Amazon, running our primary and our DR site there. So the results, wire to wire for this, it took 5 months. Great job by our operations team executing this. They were squeezed on resources because not only were they doing this, but they're also making sure that the current, the existing production workloads were running. They were able to execute this efficiently. We see that our performance and uptime has been significantly improved, and we did see an instance where an availability zone failed, and it was great to see that was really just a slight blip for us. We barely even noticed. I mean, it was like, about 10 years ago, I was commuting into work on the first snowy day of the year. I live in New England, and I'm coming up to my office. I'm probably about 400 yards from my office. I can see my office, and I say, "Oh, look at that! There's a fire truck, stopped there, and he's turning into the parking lot before my office." I'm like, "All right, I'm going to have to slow down before I get to that fire truck." I touch the brakes. My car does not stop at all. Like, I am just, the brakes are not working. I'm on black ice, and I'm sliding towards this fire truck. So the first thought going through my mind is, I'm going to hit a fire truck. And I hit the fire truck. My car was totaled. I'm pretty sure the guys in the fire truck, they probably didn't even spill their coffee. They didn't even notice it. So that's what you want to do with your architectures. You want to build a highly reliable, highly available architecture so that when these bumps occur, you don't even notice it. So really powerful, leveraging multiple availability zones. And also, the spook factor is gone. Developers now were at a point where they had a much higher confidence level in the infrastructure. So as we were looking at our performance characteristics from our production workloads and trying to tune that or resolve an issue, we knew the infrastructure level was not going to be a problem for us, and we can just focus at that application tier. So that really helped speed up the efficiency of our development operations team. So what's next for us? For Transportation Hub, we do want to look at now moving that from the lift and shift pattern to a cloud optimized pattern. So one of the things we're looking to do is implement RDS. Abdul here, he's here specifically at the show, looking for how can we move to RDS. We're using MS SQL. We need to replicate across multiple regions. What's the best way to do that? There's some limitations with RDS that we haven't figured out, so we're here doing research. We think we might actually have a potential solution with leveraging a partner solution from the Amazon Marketplace that can help us with that. Also, the dev team is looking to streamline the deployment pipeline. So they're going all in on Amazon for their continuous integration and dev and test environments. And they're looking to leverage additional services to speed the productivity of that team. So I'm going to talk a little bit now about another shipping solution that we have. It's called BorderFree. So BorderFree is another global e-commerce solution and allows retailers to either integrate with an international marketplace to add their listings into an international marketplace, or a retailer to directly expose their current web presence internationally. So BorderFree does things like website localization, currency conversion. It'll handle, it'll present, it'll do that landed cost calculation to help figure out the shipping costs across international borders. It's a tremendous solution. And actually, we're in the holiday period now. If any of you have a spouse that likes high-end fashion or those types of items, you can go to BorderFree.com, see a listing of our retailers that we partner with that leverage our BorderFree solutions. So if you want to buy something from Harrods, you can do that, and they'll ship internationally to the U.S. It's a really cool, really powerful platform. So Pitney Bowes, we acquired BorderFree, I think it was last in roughly June of 2015. And they have a primary site that's in a colo center, and they did not yet have a DR site. So heading into this holiday period, it was really important for us to get that DR site set up so that these retailers can rely upon and see that Pitney Bowes is going to deliver the level of assurance that they expect from the Pitney Bowes name. So we executed a lift and shift program for that to stand up a DR site in Amazon. The primary site is still running in that colo data center right now, but that DR site's active. But we are really doing some really cool things now. The BorderFree development team is really motivated to move that application, which is very much a monolithic architecture application, move that to our cloud native pattern. So they're breaking up that monolithic app into separate services, and where possible, they're moving from Windows to Linux. So we're envisioning running these services on Amazon Linux. They're going all in on a CI environment in Amazon. So I want to talk a little bit about this. They've deployed a Jenkins farm up in AWS, the Jenkins master and Jenkins slaves. They're fanning out build jobs to speed up their builds to make them more efficient. And as they are breaking up this monolithic app into smaller services, they're changing their testing profile. Previously, their testing profile was very, very heavy on UI testing because it was a monolithic app, and it was really the only way to interface with it was at the UI tier. So they had a lot of automated tests built out, but a lot of those tests were very fragile. It took a long time to run, not very efficient. As they've been breaking up this monolithic app into smaller services, they've kind of flipped that profile from heavy UI testing down to only a few unit tests. Now they have tons of unit testing that runs with every single build. Then they have a high number of API-based tests that happen at the business service tier, and then only a few fragile UI tests that they need to run with each cycle. So they're really going all in on that to speed up their developer productivity, speed up how quickly we can get developers' feedback about the quality of their code change. They're also looking at trying to implement infrastructure as code. So we're defining all of our AWS resources as CloudFormation stacks. We're packaging the application tier in Docker containers, and we're leveraging Ansible for orchestrating the deployments. Do we have any Ansible users here? We have a couple. So here's our target state for this environment. So we have version control. It's still running actually on-prem in our private data center. When we want to deploy, we fetch from the version control system our Ansible playbooks. The Ansible controller takes those playbooks and generates our CloudFormation templates. The CloudFormation templates then drive the creation of the environment in Amazon and provisioning of all the EC2 instances. Then we fetch the Docker instances from our Docker registry onto that, and we're up and running. It's a much more efficient way to get new code into production than a traditional pipeline. So this is kind of the target. This is our next target state, and the team's already looking at the next steps beyond this. One, we want to move our version control system into the cloud. We use GitLab in Pitney Bowes. We like some of the features of GitLab. So we're probably not going to go all in on AWS on their version control system, but we are going to stand up GitLab in the cloud so that our builds will be more efficient. So you don't have to fetch the source from our data center, get the assets moved up to the cloud. You can do all the builds right there locally in Amazon. And also, we're looking at potentially implementing a container management service, either ECS or something like Kubernetes. We have a lot of these small services that are running. We actually had an intern this past summer that did a proof of concept for us with Elastic Container Service to prove out that this could be an effective way for us to take a lot of our smaller applications and run them more cost effectively. We were seeing that we're standing up separate Beanstalk stacks for dozens and dozens of services, not very efficient cost-wise. So we wanted to load these into Docker, into a container management service, and then let that container management service pack those resources onto as few EC2 resources as it can, while still ensuring the quality and reliability of those services. So I think it's got a lot of potential for us. So once we land on this target state, I'm sure we're going to be on to the next thing beyond that very quickly. So for WrapUp, we were faced with an aging infrastructure. We had some decisions to make in terms of who we were going to partner with. We landed on Amazon as being our strategic cloud provider, primarily based on cost and developer productivity. What we've seen for what we did with the transportation hub has fully borne out that we're more effective cost-wise. We've calculated that we've saved 8% on our hosting costs. Now, bear in mind that that's not a huge number, but that does not factor in the fact that we had to replace all of our server and networking infrastructure. So that 8% was just keep on running the same infrastructure that we're running in our colo data center and just pay for the maintenance and the hosting staff that we need there. So what does that cost versus what's it going to cost to go to put the transportation hub, add high availability, add DR in Amazon, and we still lowered our costs. If we had to reinvest in capital hardware, it would have been an order of magnitude of savings if we calculated that out. Developer productivity-wise, we've seen some huge wins across the company in terms of, especially for some of our SMB-oriented SaaS product teams. They've been able to get new apps out the door much more quickly by streamlining a build pipeline that leverages Amazon for our development, QA, staging, pre-prod, and prod environments. It's a very powerful thing to get your developers experience with. For Amazon cloud adoption patterns, lift and shift, cloud optimized, and cloud native, evaluate where each product is in your product lifecycle. Obviously, more mature products that are on the downslope of their lifecycle, probably not looking for. You're probably not looking to invest a lot of development resources. Maybe lift and shift is more appropriate. You're building a new app a product manager has a twinkle in his eye about some new use case, and you want to build some new apps, and you want to quickly experiment. Look for a cloud native type architecture. Leverage everything that Amazon can give you for developer productivity, scaling, maybe even serverless. And then in the middle, cloud optimized. Maybe you have an asset that you want to repackage up and bring to a new market, but you have the opportunity to invest in development resources to make it more efficient. Look at separating compute from storage by looking at S3. Look at adopting CloudWatch for monitoring. Look at CloudFormation for automating your deployments. So we successfully moved the transportation hub, and we added high availability and disaster recovery. And BorderFree, we are now actively migrating BorderFree. We're basically going right from lift and shift, trying to make the jump all the way to cloud native looking at building out our CI environment fully in Amazon, leveraging Ansible and CloudFormation for our deployments, and also looking at Docker for packaging up our application containers. And with that, I think we have time for questions if anyone has questions.